Alright, welcome back everyone. Today we're looking at exercise 8b. This is two-way tables and Venn diagrams. We've done a bit of this before, so it shouldn't take very long. There's a bit of notation there about sets and that sort of thing. Venn diagrams must have a rectangle around the outside. Please make sure you are doing that. I know a number of you are not, as of last year. Let's hope we remember this year. A null or empty set is a set with no elements, and we can just have an empty set of brackets like that, or the little zero with a line through it. That's the null set. All elements that belong to both A and B, if we want to say things that are in both set A and set B, that would be the intersection there. That's why it's called the intersection. We write that as A, and it looks a bit like an N, but it doesn't have a stalk. It's just an upside down arch, like they're playing croquet. A intersects B is how we'd read that, or A and B. If it could be anything in set A or set B, A or B, that's the union of the two sets. And we say A union B, or A or B. A couple of definitions you may not remember from last year. Sets are mutually exclusive if they have no elements in common. And what would that usually look like if I was to draw a Venn diagram for them? I would have set A over here, set B over there, and no intersection between the two. Fair enough. And if we want to write the complement of event, or something, so if an event is let's say rolling a 6 on a die, then the complement of that would be not rolling a 6. If the event was A, then we write A dash or A prime, or sometimes just not A as well. And later on you'll see notation like this, which also means not A. So a number of different ways of saying we don't want set A, or the complement of set A. As always, the sum of our probabilities is 1. So if I want to know what's the probability of not getting A, I can just do 1 minus the probability of getting A. A only is defined as the elements in A but not any other set. If I was to look at, again, just two sets A and B, A only will be the elements in set A that are not also in set B, so not that little bit in the intersection. Venn diagrams and two-way tables, we've seen these before. Let's jump into the exercises. I know you're itching to start your maths and you just want me to finish, so let's get into it. Consider the given events A and B that involve the numbers taken from the first 10 positive integers. A is a set of numbers 1 to 6, the numbers that appear on the faces of a die perhaps. And B are the numbers 1, 3, 7 and 8. Don't know why they chose those, but they did. Represent the two events A and B in a Venn diagram showing the number of elements belonging to each region. Alright, so here's my Venn diagram. Not particularly beautiful, but I've drawn worse. What I'm going to do, I might just... it's got everything there. Let's get that. Just go copy, because I have a feeling I might need another one of those later on in the video. Here's set A, here is set B. So in set A I have 6 elements in total, but how many of them are also in set B? Let's just use a highlighter and check. Number 1 is in both sets. Number 3 is in both sets. 7 and 8, well, they're not on the faces of a die. So there are definitely 2 numbers that are in the intersection that are in both set A and set B. So what I'm going to do, it says to show the number of elements belonging to each region. Well, there are definitely 2 that are in the intersection. How many others are there then in A? Well, there are another 4 there. How many others in B? There are another 2. 4, 5, 6, 7, 8, but we knew that the number of elements was supposed to be 10, didn't we? So there must be 2 numbers that were not represented in either set A or set B, and you've probably already figured out that they were the numbers 9 and 10. List the following sets. So what are the elements in the set A intersects B? Well, we've already highlighted them above, haven't we? 1 and 3. What about the numbers that are in either set A or set B? Remember, that can include both as well. What's 1, 2, 3, 4, 5, 6, 7, or 8. 9 and 10 do not appear in either set, although they are among the first 10 integers, so no good. If a number from the first 10 positive integers is randomly selected, find the probability that the following events occur. The probability of getting something from set A, well, there are 6 in total inside set A. So the probability that a randomly selected element is from set A would be 6 out of the 10, which you would of course simplify down to 3/5. What about the probability of getting a number that is in both set A and B? Well, there are only 2 out of the 10, which of course will simplify to 1/5. And finally, A or B. Probability of A or B. You'll notice I did the PR that time. I think your book does PR. Some books do, some don't. I'll go back to trying to be consistent with your book. So the probability of A or B, 4, 5, 6, 7, 8. There are 8 elements altogether in either A or B, so it's going to be 8 out of 10 or 4/5. Are the events A and B mutually exclusive? Of course not. Why? Because the probability of A and B does not equal 0. Or you could say, just as easily rather than probability, the number of elements in A and B is not 0. There is at least one element in each set. There are some for you to try here. Again, it's first positive 10 integers, slightly different values. Pause the video, do exactly what I did just then. I'll see you back once you've done that shortly. Good luck. All right, you've got a chance to check your answers there. Hopefully our answers match each other's. Just pause if you need to. I'm going to move on and show you the next example. I imagine most of you are travelling A-OK with this. Let's have a look at the next one. Using Venn diagrams. From a class of 30 students, 12 enjoy cricket, 14 enjoy netball, 6 enjoy both cricket and netball. Illustrate this information in a Venn diagram. There we go. Now I think when I try to expand this, it only does one little bit at a time, which is kind of silly, but that's okay. We can cope with it. Drag that one over a little bit. That looks good enough for us to work with. Well, they've given us the names of the sets, haven't they? C for cricket, N for netball. The total number of people in this class was 30. And it's usually easiest if you start with the intersection. 6 enjoyed both cricket and netball. Let's put the 6 in there. Altogether, I'm supposed to have 12 in cricket. I've already got 6, so I need another 6. I'm supposed to have 14 for netball. I've got 6. That's another 8. 12 and 8 make 20. How many do not enjoy either cricket or netball? 10 on the outside there. State the number of students who enjoy netball only, so netball and not cricket. Well, that would be 8 out of 30. But they only want to know the number, so it's 8. How many enjoy neither cricket nor netball? We've already answered that, haven't we? There are 10 on the outside. That must be the answer. Find the probability that a student chosen randomly from the class will enjoy netball. Well, there are 14. So the probability they come from set N, the people who enjoy netball, 14 out of 30, which would be 7 out of 15. Probability they enjoy netball only, so N and not B, not cricket, which is a C. This time it's 8 out of 30, which would simplify down to 4 over 15. Both cricket and netball, that's 6 out of 30. C and N for netball. Cricket and netball, 6 out of 30, which is, of course, 1 in 5. As always, an example for you to try to the right. Pause the video, have a go at it first, then come back and check your answers. And we've only got one last little bit to show you. See you shortly. And there you have it. Let's talk about foods making me hungry. Fresh meat, yum. But not right now, and probably at least a little bit cooked. I like it warm, not totally fresh. Nice rare steak could be good about now. All right, last example we're up to. Using two-way tables. Venn diagram shows the elements in the two sets A and B. Transfer the information in the Venn diagram into a two-way table. What do our two-way tables look like? You probably remember, but let's just take it through. We have set A, and either you're in it or you're not in it. And I'm going to have another little section over here for the total. Similarly, going the other way, I've got a set. You could be in set B or not in set B. And we've got a total here. And it's just a matter of transferring the information. How many elements do I have altogether? 2 and 1 is 3, and 6 make 9, 10, 11, 12. 3 and 3, 6, and 6 are 12. Check it another way. Oh, I think that's what I agree with. This first box here, this is for elements in set A and set B. So the intersection, there's only 1. How many are in set A but not in set B? That refers to those people there. 2. Altogether, I should have 3 inside the circle for A. Indeed, I do. And what about in set B but not in set A? Looks like there are 6 people there. Not in set B and also not in set A. So in neither set, there are 3. Let's do our adding up and make sure these work. 6 and 3 is 9, 3 and 9 make 12. What about going across? 2 and 3 make 5, 1 and 6 make 7, 7 and 5 make 12. So again, you can read the same information off a two-way table or a Venn diagram. Let's just verbally answer these. You don't need me to write them all down. Number in A and B, 1. Number not A and B, 6. The number in A and not in B, A and not B, 2. The number in not A and not B, that's those 3 right there. The number in A altogether, that's the total, go down to the bottom, 3. The number that are not in set B, it's a total of 5. The number in set A or set B, so I can just add them together, 2 plus 1 plus 6, 9. Note when you're trying to do it from the table here, I can't just go 3 plus 7 because that one got counted twice. 3 plus 7 is 10, but I've got to subtract that A and B because I counted them twice. That will get me back to 9. And then the probabilities we can fill in as well. Probability that they are in set A and B, 1 out of 12. Probability they are not in set A. Well, there are 9 out of 12, so that would be 3/4. What about the probability they are in set A and not in set B? In A, not in set B, that's 2 out of 12, or 1 in 6. I'm confident you can do that. There's another one for you to try, but I think the video's gone on long enough. You're itching to do your maths. Go and do it. Enjoy, good luck, have fun. I will catch you in the next video. Bye for now.